Okay, class, we're going to go ahead and review the homework that you took home today. So let's look at problem number 1. If we remember order of operations, we're going to start inside parentheses. So I'm going to look here and check, can I add anything in there? Can I combine anything? And I look and I have 3x minus 4y. Now, if we remember, we can combine like terms. Now here I have a number that has a variable x and one has a variable y, so they can't combine. So inside parentheses, I'm done. So what I'm going to do is look outside and see is there anything outside the parentheses. There's a 2. We notice that that 2 is right next to parentheses. There's no sign in between, so that means that we multiply. Now, we're going to take this negative 2, the whole thing, including the negative sign, and multiply it times everything inside the parentheses. So negative 2 will multiply times 3x, and then negative 2 will multiply times, negative 2 times negative 4y. So negative 2 times 3x, that's a positive and a negative, so we get negative 6x. Now right here I have negative times a negative, so that's going to be positive. 2 times 4, I get 8y. So my answer would be negative 6x plus 8y. So even though we have x and y still there, that's our answer. We don't know what the variables or what their value is, so we're going to leave them as is. So if we jump to the next problem, again, I'm going to look inside parentheses. And I notice that I have 10x plus 7y minus 3x. Now, I can use commutative property and I can move these numbers around. So what I'm going to do is move the negative 3x. Now, I have to move the sign in front of it also. And I'm going to put it here to make it a little easier, plus 7y. Now I look again, combine like terms. I see two numbers have the variable x. I can combine them, 10x minus 3x. I end up with 7x plus 7y. Again, take this, multiply it times everything inside. 5 times 7x, 35x, plus 35y. Okay, so problem number 3. Right here, I'm looking, there's no parentheses. So what I'm going to do is just combine like terms. Now, one of the best things you can do is use commutative property to put those numbers next to each other so that way when you add or subtract, it's a little bit easier. Now when you do that, you need to take everything that's in front of them along for the ride. So here I have 10x, and I want to put anything else that has a variable x right next to it. I see a 5x. What's in front of it? Plus sign. So plus 5x. Now I have minus 3y. And I'll put that y right behind it with its plus sign. Now, 10x plus 5x. Well, 10 plus 5 is 15. There's 15x. Negative 3y plus y. If I remember my negatives, negative 3 plus y, which remember is the same as saying 1y. Negative 3 plus 1 becomes negative 2y. There's our answer. Okay, now this problem might be a little more difficult. I'm going to look inside parentheses. Here, 2x minus 3. One number has the variable x, the other one does not have variables, so they cannot be combined. Here I have 4 and 5. No variables, that means they can combine. So let me rewrite my problem so that I have that work done. Minus, in parentheses, 4 plus 5 is 9. Okay, so now I look, okay, 4 times 2x, 8x, minus 12, and then minus 9. The reason this is minus 9, I remember this minus sign is right outside, but imagine it's negative 1. Negative 1 times a positive 9 gives me negative 9. Now, I'm still not done because these two can combine because they're like terms. 8x, negative 12 minus 9, think of it as you owe $12, then you owe 9 more, negative 21. Okay, now let's state if the following pairs of expressions are equivalent. Now to solve this, what we need to do is make sure everything is expanded or simplified down to their final form. Now if I look on the left side, starting from left to right, here I can still do some work. I look inside parentheses, there's nothing that can be done. 3x minus 2, nope, can't combine them, can't subtract, can't do anything. So now I multiply 3 times 3x, that's 9x. 3 times a negative 2, negative 6. I look and I notice right away there's a 9x and a 6x. So my answer is going to be no. Okay, right here on B, I look, simplified. Here, not simplified. But I look inside parentheses and I notice, okay, you know what? Everything that can be combined has been combined. There's no like terms. So I look outside, parentheses, I find a 5, time to multiply that 5 times everything inside. So I get 5x, 5 times a negative 2, negative 10, y, 5 times 4, plus 20. Now I look again, okay, the 5x is the same, negative 10y is the same, plus 20 is the same. So this one is going to be yes. So as we continue down, this one is simplified, this is not simplified. Here I get 6x plus 30y. Even though they look similar, I have to notice that right here, there's no negative sign. That's a positive 6. A negative 6, they're completely opposite numbers on the number line. So this is no. Even though they look the same, that negative sign makes a big difference. I've mentioned before, who wants this and who wants this? Nobody wants that negative 100. Nobody wants to owe $100. So don't forget, negative signs, very important. Okay, finally, x minus y. Here I have x minus y, but I have a negative sign outside. Now remember, that's like saying negative 1 times x minus y. So negative 1 times x, which is the same as positive 1x, would be negative x. Negative 1 times negative y, which would be like negative 1y. Negative times a negative would be y. So right here I have positive x. Right away, just looking at the first ones, I can tell the answer is going to be no. As soon as I see a difference, the answer is no. They're not equivalent, because equivalent means that they're equal to each other. Okay, so Mr. Huerta makes $15 an hour for every hour. Now, he worked 5 hours, so now I know that he worked 5. So my expression is 15H, because I didn't know how many hours till I read more along in the sentence. Now I see that I worked 5 hours. So 5 times 15, this is 5 plus 2, so I made $75. And then finally, our last question. So he makes $15 an hour. He wants to buy his wife a nice birthday gift. He sees a diamond ring that costs $2,750. How many hours will he have to work? Well, if I need this much, and I'm only making $15 an hour, to figure out how many hours I'm going to work, well, let's say I work 1 hour, that's $15 towards the $2,750. 10 hours, that's $150. So in order to figure this out, what I'm going to do is divide. Now, let's go ahead and rewrite this a different way. 15 into 2,750. 15 does not go into 2, but it goes into 27 one time. That's 12. Bring down the 5. Now, how many times does 15 go into 125? Let's see, 10 would be 150. So let's try to figure this out. Let's see. Okay, so it's going to be 8 times. Now, I already brought down the 5. Let me bring down this 0. Okay? 15 goes into 50 at least 3 times. So Mr. Huerta is going to have to work 183 hours. Okay. So how can I double check this? Well, again, we do the opposite of division, which we just did. $2,745, so about 183 hours. So that is going to work. So let's say 183 hours. Well, how many days can he work? Well, how many days will he have to work if he can only work 6 hours a day? Again, every 6 hours is 1 day that he's allowed to work at his job. So we're going to divide again by 6. So 183 divided by 6, 3, it's 18, 0, bring down to 3. So about 30 days it's going to take him to buy that diamond ring. There you go. Okay. And there is my answer.